This video will cover section 3.4, polynomial functions, and really all there is to this function is looking at the end behavior of polynomial functions, the graph of polynomial functions, and graphing a few simple polynomial functions. Alright, so we've looked at polynomial functions, quadratics, so on and so forth, but they've been very basic polynomial functions with only one term to maybe three terms if we're thinking in terms of quadratic functions. But polynomial functions can have many more terms, and so to look at the graph, they can do lots of things besides just make a U upside down or whatever, or make certain one little bend. They can have multiple things going on in the middle, but what we're going to look at are the end behaviors, so the left end of the graph and the right end of the graph, and we can tell some things about that by just simply looking at the function itself. Alright, so when we look at the function, what we're going to do is we're going to look at the terms, and really all we're going to look at is the first term. We have to make sure that they are first written in descending order by exponent. So you're going to look at the letter, the variable, and then its exponent, and make sure that they are in descending order. Alright, and from that, once you get them, make sure they're in descending order, then you can look at the very first term, and all we're going to look at is the leading coefficient. Alright, and that's going to be your A, the leading coefficient, and then we're going to look at the exponent of that first term, and that's going to be our N. Alright, so what we're looking for is whether the leading coefficient, that's that number in front of the variable of the very first term, whether it's positive or negative. And then we're going to look at the exponent of that same term, looking at the exponent of the variable, and we're looking to see is it an even or an odd number. Alright, based upon that we can tell the end behavior of the graph. So looking here at this chart, it says if A is greater than 0, so that means our leading coefficient is positive, and our exponent is an odd number, that's 1, 3, 5, 7, 9, so on and so forth, our graph should look like this. Facing down, the right side facing up. Alright, if our leading coefficient is negative, less than 0, and our exponent is still odd, alright, the end behavior is going to switch. The left side will be going up, right side down. Alright, then looking at if the A is positive, but this time the exponent is an even number, it should look like this, both ends going up. And if it's less than 0 or negative, our leading coefficient is negative, then both sides should be going down. Alright, the way to remember it is your choice, really. Notice that on these two, the exponents are odd, so you can remember the odds, or the evens. Alright, and then base it off of the leading coefficient, or you can base it off the leading coefficient is positive. What's my behavior going to look like when my exponent is odd or even? Totally your choice. However you like to remember it, doesn't matter to me. Whatever is easiest for you. Alright, so we're going to look at a couple of functions and determine their end behavior, and what we're going to do is we're going to match them to the graphs below. Alright, so we're going to decide does one match graph A, 2, so on and so forth. Alright, so when we look at the function, alright, I notice that my exponents are in descending order, 4, 2, 1, and then no letter. Alright, so I'm going to look at my leading term, and that's this right here. Alright, and my A is a 1, that's greater than 0. And then my N, my exponent, is a 4. Alright, so what I'm looking for is a graph where A is greater than 0 and my exponent is an even number. A greater than 0, exponent's an even number. So I'm looking for the graph that has this shape. Alright, so when I look down here at my graphs, that should be graph C. Alright, so for number 1, it should match graph C. Okay, looking at the next one, look at the leading term. We'll first make sure they're in descending order, 6, 2, 1. Alright, so they are. So I'm looking at the leading term. Its a is -1, and its exponent is 6. So I'm looking for in behavior with a less than 0 and an even exponent. So a less than 0 with an even exponent, my graph should look like this. Alright, so when I look at my graphs, that would be graph A. Alright, on to the next. Make sure our exponents are in descending order. 3, 2, 1, they are. So I can look at my leading term here. My a is a 3, and my n is a 3. So I'm looking for the graph that has greater than 0, a, positive a, but this time an odd exponent. So greater than 0 and an odd exponent. We're looking for the graph that has this type of in behavior. Alright, so that looks like it would be graph B. Alright, and then lastly, exponents in descending order. Looking at my leading term here. Alright, my a is a -1. My exponent is a 7, so I'm looking for a less than 0, and n is odd. And that would be a less than 0, n is odd. Alright, that's the only graph left, and that would be D. Okay. Alright, now if we want to graph some of these, alright, this is the cube function. Alright, so you want to make sure you go back and look at your parent functions. Alright, so this one should look different than the squared function. Alright, it shouldn't be the same. This is x cubed. Alright, we're going to find points the same way by simply picking some values. And I'm going to pick -2, -1, 0, 1, 2. You can pick whatever you want. Just remember we're cubing, so the numbers are going to get big real quick with the numbers that you pick. Alright, and then we're just going to fill them in. So if I fill in a -2 for x squared, that would be -2 cubed would give me -8. Then -1 cubed would give me -1. 0 cubed would give me 0. 1 cubed is 1. 2 cubed is 8. Alright, then I simply plot my points. So here's my point, 0, 0. Then, let's see, right 1, up 1. And right 2, up 8. 8. Alright, and then we're going to go left 1, down 1. Left 2, down 8. Alright, and if you look at the basic shape of the parent function, the x cubed, alright, you'll notice it is not a straight line because this isn't a linear function, but it has kind of a curve to it, something like that. Alright. Also, you could think about the graph. There's only one term in it. The leading coefficient is 1. That's greater than 0. And the exponent is an odd number. So our graph should look like this. Down on the left, up on the right. And that's just how our graph looks. It matches the in behavior. Alright, so the next graph is negative x cubed. So when we make our graph, it should look opposite, because that's what that negative sign means, is opposite. Alright, so if we have a negative leading coefficient, so that would be a less than 0 and an odd exponent, our graph should look like this. So what I'm going to do is I'm going to pick those exact same values, -2, -1, 0, 1, and 2. Alright, and then when I fill it in, I should get an opposite answer. So when I fill in -2, and I cube it, I should get the opposite of -8, which would be 8, because this is the opposite of -2 cubed. That would be -8, the opposite of would be 8. Alright, so let's fill those in. Alright, so that's going to be 8, positive 1, 0. Then here, when I cube 1 and take its opposite, I get negative 1. When I cube 2 and take its opposite, I get negative 8. Alright, so then we can go through and plot those points. Negative 2, up 8, left 1, up 1, and we're at 0, 0. Right 1, down 1, right 2, down 8. Then when I connect the dots, alright, I should have a little turn there at 0, 0. Alright, and notice that my graphs are opposites of each other. Okay, now the next two graphs, we could say that they are quadratic in nature. Alright, even though it's x to the 4th, I could rewrite it like this. F of x. Alright, so x squared is the exact same thing as x to the 4th. Alright, so with that in mind, alright, it's going to look a little different. Alright, it might be squished up or spread out more. But if we think about the leading coefficient and its exponent, we should be able to know the end behaviors of our graph. Alright, so I'm going to pick those same values, negative 2, 1, 0, 1, 2. I'm going to come down here and do the same thing, negative 2, 1, 0, 1, 2. I'm going to fill them in. Alright, so negative 2 to the 4th power would be 16, 1, 0, 1, and then 16. Alright, so all I did was raise all those numbers to the 4th power. Make sure when you put negative 2 in the calculator to the 4th power that you put negative 2 in parentheses to be sure that you get the correct value. Alright, and so when I graph those, alright, my leading coefficient is positive and my exponent is even. So when my leading coefficient is positive, exponent is even, my graph should look like this, both ends pointing up. So I'm going to go right 2 and up 16, and then that should have been a negative 1. Then I'm going to go left 1, up 1. I'm at 0, 0, right 1, up 1, right 2, up 16. Alright, and then when I connect my dots, it should look like this. Notice my end behavior matches what we described in the box over here on the left. Alright, now this is just simply the opposite of that. Alright, so if I take the opposite, then I should have the opposite of these values. The opposite would be negative 16, negative 1, 0, negative 1, negative 16. Alright, so I'm going to graph those values. So we're going to go left 2 and down 16, left 1, down 1, 0, 0, right 1, down 1, right 2, and down 16. And then we're going to connect those dots. Alright, notice it is the opposite of the graph above it. Both ends are pointing down. So that matches what our table says on the top of the paper up here. A negative leading coefficient and an even exponent the end behavior should be both ends pointing down.